Okay, so we're going to do the chapter, a personal finance test review. So this is the whole review. So it says the jewelry manufacturer has determined the expensive function to the necklaces to be. And what we'll put in here is what we have right here. So we are doing this. So we're going to insert those equations for the expense and revenue. And the same thing for number 2. And then it says how many necklaces does the jewelry store must sell to reach its break-even point. So that would be our second. Okay, and these are our thirds. And I'm putting 3 because we're both using them. So how many necklaces? So we want to know how many necklaces must it reach its break-even point. Remember, per break-even point, that's when the revenue is equal to the expense. So remember, for our graph, it's going to be like this point where it looks like this. Remember, and the break-even points are where those the revenue and expense overlap. So we're going to set those two equal to each other. Remember, we can have it as revenue is equal to expense. So I'm going to set it equal to, I'm going to put 150 Q plus 8,000 is equal to $185.56 Q. And then we want to get the Q's all on one side. So I'm going to subtract 150 Q from each side. Remember, we are subtracting money. So it's going to be 185 and 56 cents minus $150. So we get $35 and 56 cents. And 150Q minus 150Q is 0. We bring down the 8,000. And now we're going to divide by $135.56 by each side because we're solving for Q. I'm going to get Q all by itself. And remember, we're going to do numerator divided by the denominator when we enter this into the calculator. So it's going to be 8,000 divided by 35 and 56 cents. And I got for Q, I got that it's equal to 224 and 97. Remember, we normally would round to the hundredths place, except for this is an item. Remember, if it's 5 and up, we're going to round it up. So we're going to round it up to 225 necklaces. So to reach their break-even point, they'd have to sell 255 necklaces. Let's go ahead and do the second equation. So we're going to set 130. So this is for number 2, this is for number 1. So 130Q plus 70,000, and I'm going to put that as 70K. So 7,175.61 Q, and we're going to deduct it from each side. So we're going to have 70,000, okay, is equal to $45.61. Again, we're still getting the Q's they want to get the Q by itself, so I'm going to divide by 45. $61. Remember, it's going to be numerator divided by the denominator again. So we go ahead and enter that in the calculator. And for Q, I get that it's equal to 153.47. But remember, it's money, so we're going to round 5 and up, round it up. So we're going to leave it as 153 necklaces. So what that means is that the company needs to sell just right on this 153 necklaces must be sold to reach the break-even point. For the next one, it says write the expense function. Okay, so we have this, everybody. So this, remember, is our demand function. This is our expense function in terms of Q. They want us to write the expense function in terms of P. Okay, so we're going to do that right here. So I'm going to do it up here. Write the expense function in terms of P. Okay, so that means we have to substitute in. So we're going to go 5. Sorry, let me go back. Okay, so we're going to write E is equal to, so expense is equal to. I'm going to substitute this in for Q into that function. So I'm going to go ahead and substitute in. So I'm going to have 5. Remember, keep track of the negative sign. So it's negative 140 P plus 9,000, which I'm doing as a K, plus 21,000. Again, I'm doing it as a K. So remember, we have to do our distributive property. So I'm going to have to multiply. So it's going to be E is equal to, and we multiply it, so negative. Okay, so negative 140 Okay, so remember, keep track of that negative sign, so it's going to be negative 700 plus, and then 5 times 9 is 45. Okay, we're going to combine like terms, so we're going to add these two together. So it's going to be E is equal to negative 700 P plus, we add those two together. So that's going to be 66,000. Okay, so that would be our equation for A. So that would be our final answer for this one. Okay, it says a price of 25. How many widgets are demanded? Plug and chug for Q. So we're going to be putting it into our demand function. Remember, that's our demand function. So we're going to substitute it in. So it's our demand function, not our expense. So it's Q is equal to negative 440 times 25 plus 9,000. Make sure you keep track of that negative sign. Okay, so we get 5,500. Okay, widgets are demanded. So that's how many widgets they want. I just like saying that word, widgets. Okay, so next one, it says how much does it cost to produce? How much does it cost to produce the number of widgets from part B? And we're solving for E. Okay, so we're going to substitute it back in. So we're going to use this equation. So we're going to go E is equal to, so I have the 5. I'm going to substitute this in for Q. So I substitute in the 5,500 plus the 21,000. Make sure you count the zeros. So the expense, so the cost to produce 5,500 widgets would be $48,500. Okay, so this would be the cost. So this is the cost to produce. Next one, so Victoria is making a lawn chair from recycled aluminum and fabric products that cost $15 to make. The fixed cost is $900. She determines the demand function to be, and we have Q is equal to negative $1,200 P plus 7,500. So the cost to make, okay, so this is the cost to produce them. It says write the demand function in terms of Q. So this is going to be our variable cost. Remember, this is our variable cost, and our fixed cost, so this is our F. So remember, it's V, variable cost times the quantity that you're making times the fixed cost. So I'm going to substitute that in. So it's going to be E, expense function is equal to 15 Q plus 900. And that is our expense function in terms of Q. To write it in terms of P, we're going to have to substitute in this in for Q. So we're going to have to substitute it in. So for B, I'm going to write it as, so I have 15, so I'm using the function that I wrote from before, so 15. I substituted this in, so negative 1,200 P plus 7,500 plus 900, which was the fixed cost. Remember, I'm going to distribute, so that means I have to multiply by everything in the parentheses. Make sure you remember that this is a negative. So we're going to go ahead and multiply that. So I get negative 18,000 P plus and notice this is not a negative right there. And then it's going to be 15,000. So So 112,500 plus 900. Remember, we need to combine like terms, so I'm going to add those together. So our expense function in terms of P is going to be negative 18,000 P plus 113,400. Next one, so we're still going to write it in terms of Q. Okay, so it says Anthony is making a lawn chair from recycled aluminum. Cost $25 to make. Fixed cost is $850. She determines the demand function to be, so they give us the demand function. Notice, keep track of the negatives. So remember, it's going to be variable times the quantity plus the fixed. So we're doing the same thing that we did before. So it's going to be E is equal to cost to make is our variable cost. This is our fixed. So I'm going to put 25 times the quantity plus 850. That's it. That's our answer for that one. Okay, it says write the demand function in terms of P. So that one we have to substitute in. So that's like what we did before. So we're going to have to substitute it in. It's going to be 25. I'm going to run out of room. Redo this. Okay, so B, I'm going to put over here. It's going to be 25 times the demand function, so negative 1,400p plus 9,500 plus 850. I'm going to go ahead and distribute, and then we're going to combine like terms. So I get negative 35,000 P plus, then we do 25 times 9,500 237,000 plus 850. So E is going to be equal to $238,350. So that would be the expense for B. Okay. Okay, so this one it says what is the, so I'm actually going to go to D first. So the Y max, everybody, is the Y part of the equation. Apologize, let me go back to this part because that's just ask us to write the equation. It would help if I actually wrote it correctly. So the negative 35,000 plus 238, 35. Okay, so now we got the equation. Okay, so the Y max is this part. Okay, so this is the Y max. So the Y max is the 238,350. That is the Y max. Okay. For the X max, we have to set E equal to 0 and solve for P. So we set E equal to 0, and then we have to solve for P. Okay, so I'm going to subtract this from each side, the 238,335. I subtract that from each side. Okay, this is going to end up being 0. Remember, we still want to get it by itself, so we're going to divide by negative 35,000 from each side, because what we do onto one side, we must do to the other side. So for P, I got for the X-Max, I got $6.81. Okay, and that is for the X-Max. Okay, so the next one, we're looking at our revenue and expense. So what does the dash, the curved part, represent? So the curved part, everybody, is the revenue. And the solid line, so that would be this part, the linear part. This is the expense. Okay, so that part is the expense. What are the approximate revenues at the break-even points? Okay, so that everybody means that we go here and we go across, okay? And so for this one, it's where they intersect, and they're asking for the revenues. So we're looking at the y-axis values. So that's going to be, and it's halfway between 100,000 and 80,000. So that's going to be 90,000 for the first one. And the second one is going to be right here. Okay, and I go across, and it's halfway between 40,000 and 20,000. So that's going to be at 30,000. So hopefully you all got that one. Okay, what is the vertex for this? It says a revenue for the makeup product is R is equal to, so this is our revenue equation. What's the vertex? So remember, for vertex, X is equal to, it's negative B over 2 times the A value. Okay, this is A, this is B, and we're just talking about those values. So we're going to substitute that in. So I'm going to substitute it in. Rewrite this a little better. Okay, so it's going to be negative 14,350 all over 2 times negative 457. Okay, so we're going to put that in the calculator. Make sure you keep track of those signs. Okay, and I got for X 15 and $15.70. So that would be our X value. Okay, how to find our Y value is we're going to substitute it back in. So remember, R is equal to, so the revenue is our Y value. So we're going to substitute that in. So we have negative 457. Remember, it's squared, so it's going to be $15.70. It has to be squared, plus 14,350 times $15.70. so for the revenue, I got $112,659.07. And so that would be my X value, that Y value that I would put right here. And that would be my Y value. Okay. So just so you understand, this is the Y value. So this is the Y value. This is the X value. Okay, so this would be our vertex. Okay, examine the graph. So we're looking at the graph. What are the approximate price for the maximum profit? So we're looking at the X value. So the X value is right here. We look down here, and it is 20. So it is $20. Okay, this one, the iPod company has expense function. Okay, so this is our expense function that we're going to use. The revenue function, they give us this right here. How many iPods, so how many does the company have to sell, okay, to reach its break-even point? So remember we did that on 1 and 2 at the beginning. Remember that's where expense is equal to the revenue. So we're going to set those two equal to each other. So I'm going to do 150Q plus 160,000 is equal to 250Q. I'm going to get the Q's all on one side. So I'm going to subtract 150 from each side. 150Q. Remember to bring down the 160,000. I want to get the Q by itself, so I'm going to divide each side by 1,000. By 100, I mean. Can actually cross out the zeros. These ones. Anyways. Okay. So we get quantity that they would need to sell is 1,600. So that's how much they would have to sell to reach their break-even points. Okay, number 12. Manufacturers, so business bargains, manufacturers office supplies. What's the maximum profit? Find the vertex. So we're doing just like how we did before. Okay, so this is our equation that we're going to use. Okay, this is A, remember A, B, and C. So A, B, C. So we have X is equal to, okay, remember it's negative B over 2 times A. And I do the parentheses because remember I have to make sure it multiplies first. So I'm going to substitute those values in. So I'm going to substitute in negative 7,800 divided by 2 times negative, sorry, this is supposed to be my times, negative 278. Keep track of those signs. And we're just going to put that in. Okay, so I got for my X value, I'm going to show you what I got. So remember 5 and up rounded up. We're rounding to 2 decimal places. So if I look at this one, remember 5 and up rounded up. So I'm going to round that up to $14.03. So that is a 4. Okay, and then we're going to substitute that in. back into the equation for y. Okay, so basically that's our x value. Now we need our y value. So p is our y value. They're the same. So I'm going to go negative. Main thing with this, everybody, is just keep track of all those numbers. So it's just a lot of just keeping track of everything. Make sure you're raising it to the second power. Make sure you're using the negative sign, not the minus sign. Okay, so we get for our y value is going to be $49,512. And I'm going to round it to 23 cents. So that's my y value, and that's my x value for the vertex. And we are all done. Thank you.